All right, so this is about how to use the t-table distribution. Again, if you are familiar, please try to do it on your own. Now, what we need to know here, we are looking to find the critical value of the t-test right-tailed, right? So be careful about the right-tailed, it's not so obvious. There is a little calculation for the tail in order to do it with the calculator. All right, you have the n equals to 28, alpha is going to be 0.05, and you want to answer to your either one or two, one entry or two entries, and they did not tell you how many decimals you're gonna round. All right, why? Because they're assuming that you're using the same t-table. All right, so the t-table give you, I think, 3 decimal places, so they're assuming that you're using the t-table values. Now, if you want to open the t-table, you can see the values here. All right, this is actually the t-table. All right, I'm not going to use the t-table for now yet. I'm going to do the calculator first. So what I need to know is the right tail first. So I'm trying to explain it again. So this is my normal distribution, and this is the mean. The environment is again very important. All right, the mean and the sigma. This is by default. If I'm using the t values, it's gonna be 0 and 1, very similar to normal distribution. Now, if I have a right tail, and right tail is gonna be from this side. So this value here, this shaded area, will be my alpha, which is 0.05. And all the alpha gonna go from one side because it's one tail. All right. So this is my critical value. This is where the separation, this is my reject zone. Reject 80. I know we don't have 80, but that's where the reject 80 gonna be. Now, the T critical, it will be here. I don't know it. Remember, if I'm using the calculator, all right, my calculator always requires that I feed it the left tail. So I need to give this side here to the calculator. I need to know that. And usually that is going to be 1 minus alpha. So if I do that, 1 minus 0.05, this is going to be 0.95. All right. So that's what I need to do to give the calculator. The environment is already set up. So I have the big tail area, which is this one, and I'm done. So let's see how can you do this one. So you're gonna go to distribution again. So second and vars. So now you're gonna have inverse t in there. That's what you're gonna be using. Inverse t, enter. He's asking about the area, which is 0.95. 0.95 is fine. He's asking about degree of freedom. Okay, I didn't talk about degree of freedom. If I have n equals to 28, degree of freedom is always n minus 1, which is 27, obviously, right? Let me double check. The n is 28. Okay, good then. All right, so what I'm going to put in degree of freedom is 27, and enter, enter, and enter again. So this is the value that I'm going to look for. It is 1.7. Is 1.703. Remember, 3 decimal places. Okay, that's how I do it with the calculator. 1.703. So now, suppose I did not have the calculator and I want to do it with the table. So how can I do this one? You can see here that the table, obviously, I'm going to go to degree of 28. So 28 here, 27 is here. So I'm looking for this. And I'm looking for the alpha 0.05 and one tail. So this is the value of one tail. All right. I hope you see my cursor. All right. This is the value of one tail, 0.05. And the 27 is right here. So this is the value I'm looking for. 1.703. All right, and I see here the table is straightforward, actually is much better, and that's it. But be careful, if you were using the left tail, then it can be negative, right? The calculator will give you a negative, but this one you will have to use your symmetry in order to put negative. The t values here, they are always giving you the positive values, so they are assuming that you can make a reflection and you can get right and left. All right, so the left tails are negative, the right tails are positive, and that's 1.703. okay, I think that's it. All right, I hope that's helped.